Hey, it's Mr. Allred, and we've been talking about logarithms, and we're finally going to pick up the calculator to do logarithms now. So we won't have to do them the long way that we've done before, but most calculators are kind of limited. You may have variations, so it does make it hard teaching calculators through a video. But most calculators are limited to one of two things. They're limited to base 10 using this log button on your calculator, or they're limited to base E using this ln button. So pretty much any scientific calculator has these two, but we've also seen other bases, right? So you're going to need quite a bit of practice to feel comfortable with this, but let's give you a little bit here. So the first one that we're going to do is log 35, and there's no base written, so it's understood to be base 10. So we're going to go to the calculator and we're going to get something out. Now for some of you, you'll type in the log button, enter 35, and then hit equals. So that's for some people. For some other people, you'll type in the 35 and you'll hit the log button and it will give you the answer. But here's the answer you should get. So you'll figure out your calculator fairly quickly, or you'll figure out you have problems. So I'm going to round this to 4 decimal places, but you would have more on your screen. It should give you 1.54406, so I'll round it to 1 here. So that's rounded off a bit. Now that's log base 10 of 35. So essentially what that means to you is that 10 to the 1.5441 is about 35. So keep in mind what log means. So it actually has a meaning to it, not just some weird number. So the other button you have is base E. So let's do the same number. Natural log of 35, which means it's understood to be base E. So very similar here. Some of you have the ln button. You'll type in 35 and equals. And then others of you may have the other calculator where you'll hit 35 and then you'll have the ln button, and it should give you the following answer. It should give you about 3.5553. Of course, that keeps going on. So these are different bases. So you would raise those bases to different exponents to get 35. So that would basically essentially means e to the 3.5553 is about 35. So do these on a calculator and try to use a consistent calculator so you don't have questions about how to use it when you pick up a different one. Use the same one and you won't run into problems. On all my tests, you're able to use a calculator but not a phone. So make sure you have a calculator you can use. But let's continue our discussion and notice that we only solved 2 problems here. The log of 35, which was base 10, and the natural log of 35, which was base E. So for other bases, usually the calculator is not built to handle that. So we have this formula here called the change of base formula. And technically we can change a logarithm of any base to any other base that we want. But since our calculator really only likes 2 bases, base 10 and base E, we're going to stick with those 2. So the change of base formula is log base A of B, and that could be changed to log of B over log of A. So both of those are base 10, so our calculator would handle them. Or we could change it to the natural log of B over the natural log of A, which are both base E, which our calculator could handle. And it will give us the same answer because it's the same ratio. So The example we're going to try here is log base 5 of 35. So we're going to rewrite that using the change of base formula as log of 35 over log of 5. Now log is a function, it's a command telling you what to do with those two numbers. So it's not algebraic, you can't cancel it out. This is not 35 over 5 equals 7. So we're going to do the log of 35, however you have to put that in your calculator, divided by the log of 5. And the answer we should get to 4 decimal places is 2.2091. And what's that mean? It means 5 to the 2.2091 is about 35, which makes sense because 5 to the second power, 5 squared, would be 25, and 5 cubed is 135, so it must be a number between 2 and 3. But make sure you're getting this number, and we're going to get a little bit of practice on the next couple of problems. Okay? You can find tons of log examples to put in your calculator to make sure you're getting the right answer, but make sure you're getting the right answer or ask questions if you can't. Alright, so here are 3 logarithmic equations that I want to solve. And I picked these 3 for a couple of reasons. The x is in a different position in every single one of them. Now there's nothing crazy going on here, they're all very simple. But we do different things or handle it differently depending on where the x is. So the first one, log base 12 of 72 equals x. So if we're solving for x, x is already by itself. But we have no idea what log base 12 of 72 is. So we want to put it in our calculator and see what that number looks like. It's not base 10, it's not base e, so we're going to have to use that change of base formula. So it would be log of 72 over log of 12 equals x, and then I'm going to put it in the calculator. So that's still an exact number, but if I want to know how big that number is, log 72, and I need to close the parentheses if yours is adding one there, log 12, and I get about 1.7211 to 4 decimal places. So 12 to the 1.7-ish is 72. Okay. So the next problem I have is log base 9 of x equals 4.5. So in that case, the x is inside the logarithm. It's not the base, but it's inside the logarithm. So to get it out of the logarithm, I'm going to change it to exponential form. So that'll be 9 to the 4.5 equals x. And now the x is by itself, and I can go to the calculator. So 9 to the 4.5 is about, big number, not about, is, in my calculator. Yeah, because you can take the square root of that. Okay, so this is 19,683. So your calculator should be giving you the same thing. And if you question that, you also have the change of base formula if you want to put it back in and check it a different way. The last example is log base x of 400 equals 6. The x, or the variable, is in the base of the logarithm. So it's not where we can get to it right now. So let's try and get to it. So we're going to change it to exponential. It'll be x to the 6th equals 400. So that's exponential form. I don't know of any number offhand I can raise to the 6th power and get 400. But if I want to get rid of that 6th power, I can take the 6th root of both sides. And just as a quick note off to the side here, you could do 400 raised to the 1/6. Remember, the 6th root is the same thing as an exponent of 1/6. But this would give me x is approximately, when I take the 6th root of 400, I get about 2.714. Now, in a lot of these, we have rounded off to 4 decimal places. Excuse me. So, if you went back and checked these, they might not balance out perfectly. So, if I did 2.7144, raise it to the 6, let me just do it in my calculator to show. Raised to the 6, since I rounded off, I get 399.9844. So I don't get 400. I get, just as it says, an approximation of 399.9844. So when I round off any part, I can't expect it to balance perfectly. So just kind of keep that in mind. All right, we're going to get plenty of practice solving equations in the future.